All right, we'll get started here in just a little bit. All right, folks, welcome to the webinar series. This one is entitled Breaking Databases. And specifically, we're going to be concentrating on keeping your Ruby on Rails ORM under control. So it's focused on Rails application, specifically the active record ORM and MySQL or SQL-like databases. This will basically apply to anything like MySQL, Postgres, and Mongo should also apply as well. All right, so if you Google around the internet for ORMs, you'll find a lot of articles about them, say that they're bad or in general not good. And generally speaking, the authors tend to have some good points, which boil down to that it's a leaky abstraction, which means that it doesn't fully encapsulate the complexity of the problem, and complexity can leak out in strange and unexpected ways, or that it kind of blinds the developer from not really caring about the underlying database technology and not really understanding how it works fully. And so these are really good points, and I tend to agree with them. However, you got to keep in mind that ORM is really just a tool, and like any tool, you have to know how to use it right. Otherwise, you won't get the results you expect, and it can cause some serious pain. But when you do use the ORM correctly, it gives a huge productivity boost. And this is one of the reasons why Rails is so popular with startups. In the industry, they call it like a worse is better technology, because despite Ruby being a slow language and active record being ORM with leaky abstractions, it still allows startups to execute on their ideas quickly and get to market fast. But as your startup begins to scale up, this worse is better technology choice can eventually start to show its bad side more and more. And this is where it's going to be important that you have some deep insights into the performance of your system and be able to identify these problems. And this is where a performance monitoring tool like VividCortex is going to help out. So we're going to look at some of the common ORM problems. These are N+1 queries and missing caches or missing indexes and caching. So to give you kind of an idea of what I'm doing to try to emulate these problems is that I have a Vagrant box that I've set up on my MacBook Air, and it's running Rails 4.0. And in that Vagrant box, we have a MySQL database and the VividCortex agents up and running in that box. And set up a couple of simple controllers and some simple models, the different types of problems that we may cause with an ORM. Set up two actions in those controllers. One that we call it the before action, which is going to be the code that is wrong or it has a problem, and then or the misuse of the ORM, and then the after one that correctly uses the ORM or calls the correct database tables. And then I have a benchmark script that I've written in bash that calls out to Apache AB to run the before route first for a period of time. And then after that, we'll run the after route. And while this is happening, our agents will be collecting metrics from that Vagrant box and pushing them to VividCortex. And then we'll look at the results of the UI to see what kind of improvements we've had. We also use a library for Rails called Margellina, which will be inserting comment tags into the queries. This is just a colon, comma, separated values, key values that will allow us to give us, allow us to use VividCortex to figure out exactly where in the code that query is being called, or which controller is responsible for it and which action is responsible for it. And so these are some really simple examples of commonly well-known issues with the Rails and active record ORM. The testing is done where the benchmarks are being done with not really a major workload or to scale, and so a small database, there's not a lot going on it. There's no other queries being fired, so it doesn't really emulate a production workload. So the changes are going to be pretty small, but we'll see something. And in any case, these will be good tips to help you figure out or come up with some ideas of maybe how you want to use VividCortex to find various problems in your production databases. So that's enough talk for now. Let's go over different benchmarks and the different controllers that I've set up and look at the results of the changes. So let's start with the N+1 queries. So this is a very well-known avoidable problem in active record where we're looping over a set of results and then calling out, which is going to call out to the database again, generating duplicate queries or querying the database over and over again for each one of the results in the result set. And that's not what we really want to do. We want to only try to limit the number of queries that are going to be created. And we can avoid this pretty easily. I'll show you some examples of what this controller looks like and how to avoid it. So. That's good. Sorry about this. Hold on, link's not good. All right, so let's look at this one first. So this is a simple controller. We're going to call it N1 queries controller, and the before action is just going to come up with a random offset and query the user. We're going to limit the results to 10. We're going to pass that into the user variable. And the after is going to do the same thing, but in this case, we're going to use this includes and the emails model with the same random offset to just generate a random selection from the database. And what the models look like. In this case, the user model first here has many emails. So this particular user entry, we're telling in Rails that it has potentially has many emails records. And then in the email RB file. We say that belongs to user, and this creates that association. So Active Record knows that when we query users and emails that we get that connected. And so the user schema is going to look like this. So we applied this database migration, and it's just creating a table of users who have a first name and a last name and timestamps for their creation. And then for the emails, we created a migration. It looks like this, that we set a user ID to connect or to join the users and emails, and then the string of email, which will be the email address, and we set an index on user ID in emails. So in the view layer, we're just going to render this as an HTML, simple HTML page here. This is the before. So for each one of the users, we're going to, this is basically the wrong way to do it. We're going to get all their emails and print out the email address. And then the after view, which is going to be the right way, use the include emails. So this will generate a query that looks like, we won't repeat the query over and over again. I can show you in VividCortex what that'll look like. And benchmark is that we're gonna run against this is gonna look like this. So it's just a bash script. We're just gonna run the before route first for 5 minutes, or sorry, 10 minutes, and then repeat that for the after route. And this is what it's going to look like in VividCortex. So we see that we use some tags here in the queries that allows us to use query tags to find these or to identify these queries. So we got both of them were tagged with the application equals MySQL app, and the controller is use indexes. Sorry, that's the wrong one. Sorry, this is the right one. Controller is MySQL N1 queries. So we can see in the before that the total time that these queries took over this 10-minute period was 100 or 1.9 seconds, but the after is much faster. It's only 330 milliseconds. And the total count of queries was much more. That's because these queries repeated over and over again throughout the loop, where in this case it was only each one of those loops was only a single query for each one of the results, for all the results. So they're all combined together in one single query. And CPU time was reduced as well, and a slight reduction in IO ops. So we can actually look at the queries here. Let's see if we can pick them up. So we get those by count. Why? So we can see here that this is the actual query. One of the queries here, this was probably the bad query. Let's see here with samples. So yeah, this was the before query right here. And we can see the different time and latency and that was significantly more queries being fired during that time. And top queries. And we've got the same one here. This is going to be the after query. So again, 555 total versus 5,052. So many less queries. And we can take a look here and we see, total time and average latency was greatly reduced when we were able to combine all those queries into a single query like this, as opposed to being ran over and over again throughout the loop. So that's one problem that we can solve with, or shows you what it looks like finding that problem in VividCortex using query tags. So we'll go on to the next one. All right, so now we'll take a look at the missing indexes. So for missing indexes, we did basically have a prescription. So this is a user who has many prescriptions, like medical prescriptions. We're finding a random user just to randomize the data. And we're going to be doing a joins to get the prescription for that particular user. And we're going to do the same thing in the after one, but in this case, sorry, bad prescription does not have an index on user ID, and good prescription does have an index on user ID. So we'll see how applying an index to the user ID affects the performance of the queries. So we'll be using the same user model. This case has many good prescriptions and has many bad prescriptions, so we can join those queries in active record, join those tables in active record. And then we'll look at so bad prescription belongs to user. To create that association after record of prescriptions, bad prescriptions to users. And this is what the schema will look like for that. So in this case, we've got an integer of user ID and the name of the prescription. We're not creating any indexes. That's going to be the major difference between these two tables. And we have belongs to user for good prescriptions, just like we did for bad ones. It's odd. So find this really quick. So we want good prescriptions. So in this case, we're adding an index on user ID to which will improve the performance of the query. And we'll take a look at the view. In this case, we're just going to inspect the prescriptions variable just to dump everything out of it, not do anything special with it. We'll just print it to screen. And the same thing for the after using indexes. And we'll be running this benchmark, which is just going to do the same thing we did before, this time for a total of 600 seconds for each one of the routes that we want to test with. And we'll take a look at the results. All right, so again, we tag these queries with application equals MySQL app, and the controller is use indexes, and the before and after. So adding indexes didn't make a huge performance difference as far as total time, where I think we've increased only a couple milliseconds at this scale, but at a larger scale, there'd probably be a bigger difference in this. So average latency went down a little bit. CPU time also decreased a little bit, as well as the number of IO ops also had a decrease in, which is all good signs that this is a better performing query after we fixed it. Let's see what count says, but I think it looks like the after has a slight decrease in count, but I don't think the bottleneck is the database. It's probably because running on a MacBook Air and Rails isn't a VM, probably be better performance on an actual server. Take a look at the queries here. So the ones we're interested in, these two. And take a look at the samples. So the query that was sampled is just a select on bad subscriptions from the bad subscription query. And that's where we got the comment, if you didn't see before. And here's the good one. And we can see the samples is, again, it's the same. Basically, the databases are identical, or the tables are identical. The only difference is that there's an index on user ID for the good prescription query table. Again, that gives us shows us that potentially how to use VividCortex to identify some of these problems in your database. And we'll move on to the last section today, which is going to be caching. So here's what the caching controller looks like, or user cache controller looks like. Again, just so that another routing controller. Action before was just going to pick at random an offset between 0 and 50 and limit the number of users results to 20. And we're going to do the same thing for the after route. Be using the same email and user model that we did in the first N1 plus queries example. I'm actually basically just going to be doing the after query for that. So before view looks like this. So we're just doing exactly what we did in the after of the N1 plus queries, is just looping through all these and printing out the email. The difference with the after here is that I make use of caching. We're going to use the offset as the cache key just to show an example of the cache warming up. Maybe you would use something like a user ID or some other key to set the cache, but this is going to, if the cache hits, then we won't be doing a query to the database, which is going to be faster than, well, no query is going to be faster than a query. So since the database is usually a major culprit of latency in your application. And I'll be using the benchmark script that we set here, hitting the before route and then hitting the after route with the, and collecting the results in VividCortex. And to see the results, we can take a look at that right now. All right, so we're using the use cache controller and collected the before and after here. So one of the first things you notice is that there's significantly more queries in the before. This is because that for each one of those A/B tests or these A/B requests, we were definitely querying the database for each one of those. Where the after, you can see that we've greatly reduced the number, especially after the cache starts warming up. It falls lower and lower. And the total time that was used was significantly lower than it was before. CPU time and IO ops are also greatly reduced. So that kind of gives you some examples of how you can potentially use VividCortex in your Rails application to tag queries and identify which ones are causing problems in your system, in your application, or which ones are being a performance bottleneck to you. Hopefully you found this short webinar useful. Encourage you to give VividCortex a try. We have a free trial and developer accounts and free developer accounts. Thank you for joining me, and have a good one. Bye.